Good morning. Today we'll discuss about exploring data using series and data frame. So series and data frames are two main components in Python. So by which only you can able to make some operations on the data. Okay. So the two primary data structures are called as series and data frame. So series is nothing but simply you'll be giving a list of values, comma separated values will be, suppose for example, list of values. So it is something called as an array, a one dimensional array which can hold data of any type. It can be integer, it can be string, or it can be any Python object as well. And data frame is nothing but a two-dimensional tabular data structure with rows and columns. It is similar to a spreadsheet or a table in a relational database. So what can I say is series is nothing but, for example, if you are writing only the student names, okay, in the Excel sheet if you open, and if you are noting down the register number, only the register number or only the name, a single column, means it is called a series. And data frame is nothing but whenever we feed in the data, right, feed in the data in the sense for the particular register number name, we'll feed the marks, for example. So in that case, register number is one column and the name is another column. So for example, here apple is one column, orange is one column, put together combined we call it as data frame. So register number is one column, that is series, and a separate column called as name, this is another series. And when we add these two, register number and name, add not add, so when we combine and see as a row of as a rows and columns, we call it as a data frame. So now you clearly understood that panda series is nothing but a column in a table, or it's a one dimensional array holding data of any type. Okay. And series basic, so first thing, at least you should know how to create a series. So series are a fundamental data structure in pandas and are commonly used for data manipulation and analysis tasks. So let's see the characteristics of series. So series data structure has these features like indexing, vectorized operations, alignment, and NaN handling. So indexing means each element in series has a corresponding index. As you could see in the previous image, what has happened is, so each and every element has some kind of index. So this is nothing but the index. Okay, so each element in a series has a corresponding index, and this index one, by using this index only, we can able to access or manipulate specific elements within the series. Next is nothing but the vectorized operation. So series is going to support, series supports vectorized operations, meaning you can perform arithmetic operations on the entire series efficiently, so that you can avoid the need for loops, making your code faster and more concise. Next is the alignment. So when performing operations between two series objects, pandas automatically aligns the data based on the indices. So based on your index, it is going to align it, which is going to ensure that corresponding elements are compared or combined correctly, even if the series have different lengths or indices. And the last one is nothing but NaN handling. So pandas are going to handle missing values. Those missing values only we are going to call it as null values or NaN during operations. So that means you can perform calculations on series with missing values without encountering errors. So next is, we'll be discussing about data frame. So series is nothing but only we have a separate register number column, or another file it has a only name column. Now data frame is something like when you are going to represent data as register number and name, that means you have a table of rows and columns, then it is called as a data frame. So as per the definition, a pandas data frame is a two-dimensional data structure, or like a two-dimensional array or a table with rows and columns. So it has three components: the data, which is stored in rows and columns, the rows which are labeled by an index, and the columns which are labeled and contain the actual data. So three components that are there: one is data, the second one is row, and the third one is the column. So I will show you here. So this is nothing but each row. Okay, so this is nothing but each row, and these are the columns. Okay, so rows and columns, and each and everything is nothing but the data. So now we'll discuss about what are the features of data frame. As you could see, there are 4 features, some important features like indexing. Again, data frame also provides flexible indexing operations, allowing you to access rows, columns, or individual elements based on the labels or integer positions. As you could see in series we have only a single column of data. So here you have rows and columns. So you're going to mention which row and which column value you are going to access. So if you mention that, you can able to locate the data easily. So by using this indexing only, we can able to navigate and manipulate our data. Next is column operations. Columns in a data frame are again a series objects, which means you can perform various operations on them, like filtering, sorting, arithmetic operations and all. We can able to do by using this column operations. So missing data handling, again, like in case of series what we have seen, the same way, data frames also provides methods for handling missing or NaN values. You can choose to drop rows or you can choose to drop columns containing missing values or fill them with a specific value. Finally, grouping and aggregation. So data frame supports group by operations, which allows you to summarize data and apply aggregation functions to specific groups. For example, I want to find out the average salary of all the employees. All the employees' salaries are given. Now I want to find out the average salary. Means we can able to use some aggregate functions, and finally we can able to group it or use it for analyzing. So it is useful for analyzing data based on different categories or criteria. So overall, data frames are going to provide a versatile and powerful tool for data analysis in Python, which allows us to efficiently manipulate, analyze, and summarize data too, so that we can extract meaningful insights and draw conclusions. That's all about data frame and series explanation. Now comes the explanation part of series. See, now I want to create a series. In that case, if in pandas, in Python already you know how to create a list or how to create a dictionary and all. Now in order to create a series, what you are going to do is first, for example, let's say I have created a list, something like this. List will be there within the enclosed square brackets. Now I'm going to convert this list into a series. For that, you're going to use series function and then you just pass in this data. So when you convert this and try to print it, you will be getting, so this list will be converted into a series, as you could see here. So next is nothing but the dictionary. Dictionaries are nothing but will be occurring in key value pairs. Okay, this is a key and this is a value. Now what we are going to do is again the same way what we did in list. Now we are going to convert this dictionary data into a series. So this data will be fed in. Now when you use the series, now what you are going to do is convert so the dictionary is converted into a series, and now you can able to see from this output series from dictionary. So the A1, B2 and C3. So your dictionary gets converted into a series. Now the next one is I can have a custom index by using index. So index parameter. So you can give what type of, so this is my data and this is my index. What type of index you want to have? Let's, because in case of previous two things, we had the index starts with the zeros, or here because of dictionary it just generated with the key value pairs. Now I want to set a custom index. In that case, what we are going to do is we can provide in what type of index we want to have for a particular data. So this is my data and this is my index. So the index will be of the form A, B, C, D, and this is my data. So when you use this series, you can able to create a custom index as well. So next is series indexing. As I said, so you have a list and you just convert this list into a series. Again, you have a dictionary, convert this data into a dictionary. Now when I want to print a particular data by using indexing, so series from list of 0. So in my list I have 1 2 3 4 5. So I want to find out where the series from list. In the previous slide, what you could see is, so series from list, so 1 2 3 4 5. So zeroth index is nothing but 1. So zeroth index is nothing but 1. So print of series from list of 0 is nothing but 1. So next is nothing but series from dictionary. I have created a dictionary where you could have seen A is 1, B is 2, and C is 3. So these are the keys and these are the values. Now series from dictionary of B is, what is the value? So 2, B and 2. So I want to know what is the index. So it just gives out. So next is the vectorized operations. As I said, we can able to do some arithmetic operations on two series. So let's say I have a series numbers 1, 2, 3, the other series which is nothing but 4, 5, 6. Now when I add it, it is going to give you the result. So 1 plus 4, 2 plus 5, 3 plus 6, which is nothing but 5, 7, 9. So when I call, so you can able to add series A and series B. Add these two series together, and finally the results get stored in sum underscore series. So only when you print sum underscore series, you can able to see this kind of results. And even you can able to align the data as we have discussed. So in the first series, I have 1, 2, 3 and index ABC. And the second series, I have 4, 5, 6 index BCD. So what happens here is, now when I try to add in series A and series B, okay, so wherever the indexes are common, those data alone gets copied, gets added, the remaining and all, it is trying to add the value of index A with index A in series. So index A in series A and index A in series B, but index A is not there in series B. So what happens is, it is unable to add the value which is there in series B, so it is going to gives you NaN. Whereas in case of BC we have set of data, so it is going to add the respective data and gives you the result. And as we said, like NaN handling is also possible. So as here in case of series A, we have three values, whereas in case of series B, we have only two values. Now it tries to find out A. It is not there in A, but it is going to replace it with the NaN value. So the value is missing. The remaining values and all gets added and it gets printed. So next comes the data frame. So data frame, as I said, register number, name and all. Okay. Now this is a dictionary where you are going to give values in key value pairs. So names are John, Alice, Bob, and ages are 25, 30, 36, and cities are New York, Los Angeles, and Chicago. And I am trying to print out the data frame by calling this function called data frame of this data, passing the data and print the data frame. So this is the first data frame. Now we are trying to create another data called as by using a list. So when I use a square bracket, it is nothing but a list. And then we have columns called as name, age, city. Now you can also create by using a list as well. So this is how you can create a data frame. So in order to create a data frame, you have to import the pandas library. Then you have to use this method called as data frame. So as we said, like in case of series, what we did for indexing, the same way we can also be able to do for data frame indexing. So in case of data frame indexing, so I have the data whatever we have discussed. Okay, the same data. Now what we are going to do is, we are going to access a particular field. For example, let's say I'm going to access only the name field, name column. So name has John, Alice, Bob, and then df dot loc of 0. What is my row? So you're going to access a row by a label, or else you're going to access a row by a integer position. So that is the purpose of using dot loc and dot iloc. So whenever you're going to access a row by a label, we use loc, and whenever you're going to use iloc, it is nothing but by integer position. So loc, you can even able to use the particular label name as well. Then finally comes the at. You can able to access an individual element. So for example, 0th row, what is the name? 0th row, what is the name? It is nothing but John. Okay. That's all about data frame indexing. And the column operations, whatever we have seen similar way, like what are the operations we can able to perform? Like for example, this is my data frame. By using the dictionary, now we convert it into a data frame. And now and I'm going to add a new field called as salary. So salary will be there. For example, 50,000, 60,000, 70,000. So now what we wanted to do is, we wanted to find out which salary is the highest salary. So for John, Alice, Bob, we just like assign 50,000, 60,000, 70,000. Now I want to filter out based on a particular condition. So I'm going to perform a column operation. Let's say I'm going to extract the salary greater than 60,000. Who is having, who and all having salary greater than 60,000 alone will get stored in high salary employees. In our case, only we have 70,000. So Bob is the person who gets more than 60,000. So his name alone gets printed here as per this data set. And we can also be able to sort our data frame. This is another column operations. You are going to sort by age. So by age, so you're going to sort the data by age and ascending equal to false. So when I give ascending equal to true, first John, then Alice, then Bob. Here ascending equal to false, that's why the data gets sorted in a descending order. And as we said, like in case of series, what we have done, it can able to handle missing values the same way. Here also it can able to handle. So whenever you have a missing values, you can able to handle it in a data frame as well by using. So this is our data. So whenever I have a row or column with null values, you can able to use a function called as drop any. So you can able to, so as of now in our data set we don't have any null values. So whenever you have a null values, you can able to drop that particular row or that particular column with the missing values. And whenever I have a missing values, I can able to fill that missing value with a particular value. Here in case of this one, df dot fill na of 0. That means whenever I have a null value, you are going to replace it with a 0. Like that you can able to input. So next is here, as I said, no, like for example, let's assume that we are going to have a age column and some values are missing. In that case, I want to impute that missing values means you can able to take the average. For example, 25 and it is not there, 25, 35. Take the average of these two values and that value will be imputed here. So in case of previous example. And this example, now what we are going to do is based on city and then age, you are going to find out the mean. So based on the city, so it is going to group by a column and then calculate the mean. So it is going to group by CLN. So based on this, it is going to sort it and then age wise. So based on city and age, it is going to calculate the mean. That's all about series and data frame. Thank you.